In our last section of Unit 8, we're going to discuss a life cycle assessment. A life cycle assessment is a process that identifies the environmental impacts of a product over its entire life cycle from cradle to grave. Here is a picture of a life cycle analysis. You start by looking at how do you acquire the raw materials? What happens during manufacturing and processing? What happens during transportation and distribution, usage, and then disposal? As a tool, a life cycle analysis is important for formulating policies, assisting manufacturers in reducing the impacts of their products, and helping consumers to make informed decisions. So, how do we design a life cycle analysis? There are 5 steps. First thing you do is you sketch the product's life cycle. Already done. Second thing is you identify the major inputs. So what are the raw materials and energy that has to go into each step? So you can imagine if what I'm creating is an aluminum can, then the raw material would be aluminum. The energy would be the energy required to mine it from the ground. Right? During manufacturing process, do I need an additional raw material? Potentially. I need energy because I'm probably going to have to melt it down and then shape it into a can. Going to have to transport it. That also takes energy because you've got to power the vehicle somehow. And distribution. Got to turn on the lights of the distribution warehouse. How's it used? What goes in there? And then what happens upon disposal? Does it get disposed? Does it degrade? Does it get recycled and reprocessed? What happens? Identify the major outputs to the air, water, or soil. What are the types of pollution that comes out? So here we have AE is air emissions, WE is wasted energy, WD is water discharge, W is just a general waste, and P is product. So for our aluminum can, we pull aluminum out of the ground, but we also pull a bunch of other materials, dirt, rock, whatever. That would fall under the W for just general waste. So here is an LCA schematic. We have our product life cycle here. We have the inputs needed. We have the pollutions that are identified. And notice it goes from the cradle, from the start to the grave. What happens when this product is no longer in use? The last thing we have to do, it's a 5-step process, is identify the environmental impacts. So during raw materials acquisition, do we generate acid rain? Do we generate mine drainage? Is there erosion? What else is there? During manufacturing and processing, there's air pollution, there's climate change, possibly water pollution, eutrophication, which was the greening of water, I believe, because of excessive oxygen. Right. During transportation, there's ozone emitted by cars. There's acid rain. There's particulate matter. Possible oil spills. Product use. Are there emissions there? Is there energy used there? Is there more acid rain possibly generated? During disposal, there's emissions, there's pollution for water and soil. Oh, I'm sorry. That was step 4, which was identifying the environmental impacts. Step 5 is identifying the pollution prevention options. So, if you want to prevent pollution before it is generated, you have to do that by doing source reduction and reuse and recycling rather than treatment or disposal. So in this past, we had a pyramid that had disposal at the bottom as the base. And now what we need is we need disposal to be smaller, so it looks like our pyramid is upside down, with source reduction being big at the top. So how can we reduce air pollution? We can use cleaner fuels. We can reduce the toxicity of raw materials. We can use less volatile compounds. If we want to reduce water pollution, capture and reuse the water pollutants. Use less hazardous materials. Use a double-walled tank. For transportation, transport by rail as opposed to shipping by road. Trains use a lot less fossil fuels to transport than a semi-truck does. Ship in bulk. If you can, for disposal purposes, increase recyclability. Make it more durable. Use less packaging. Make it reusable. So here's something to think about. Again, why are dumps, why are landfills more prevalent in developed countries than developing countries? Why? So remember, I think this was a slide, a picture from our first unit or a second unit, with a little guy who has made a car out of an old bottle. In the United States, what would have happened to that bottle? There's a close-up of it.